Protecting branches isn't the only way to secure a GitHub repository, not by a long shot. Let's see what other tricks GitHub has up its sleeves. Welcome to this video on GitHub and DevOps. My name is Kevin Fiesel, and I am the proprietor of Galaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. In this final video in the DevOps with GitHub series, we are going to take a look at GitHub Advanced Security, a set of tools that can improve the security posture of your organization. Because we're talking security, I think we need a different environment from the classroom. Something a bit more secure. This'll do. Welcome to the briefing room. Now let's talk about GitHub Advanced Security and what it brings to the table. GitHub Advanced Security is a set of tools that is available to two groups of people: organizations that purchased GitHub Enterprise Cloud, as well as people running public repositories on github.com. GitHub Enterprise Cloud is pretty expensive, but it is worth the price for a mid-sized organization or larger. And for the rest of us, as long as the code you're slinging is in a public repo, you can take advantage of most of this too. There are 5 major features tied into GitHub Advanced Security. The first one is dependency review with their tool Dependabot. GitHub tracks your dependencies across a series of file types. For .NET projects, we have NuGet package files. For Node.js, it's package.json and packagelock.json. For Python, it's requirements.txt, and so on and so on. Well, if you specify a particular version of a package, GitHub can check if that version of that package has any known vulnerabilities. If so, the dependency review will alert you to the issue. Even better, you can configure Dependabot to create a pull request automatically, updating your dependencies to newer versions. From there, if you have a good test suite in place, testing new package versions becomes fairly straightforward, and you can keep up to date on packages. The second thing GitHub Advanced Security offers is code scanning, using a language known as CodeQL. You can set up GitHub Actions workflows to analyze code and track any security vulnerabilities the scanner can find. As of right now, CodeQL supports a fixed number of languages. Sadly, it does not support the best language of all in F#, but despite that, it's still a good tool. The third feature is the ability to run these CodeQL scans from the command line locally. It's great that you have the ability to run a vulnerability scan when you push code into a branch in GitHub, but it's even better to run it locally before you commit. And that's just what the CodeQL CLI lets you do. The fourth feature is secret scanning. This capability hits on one of the biggest pain points for open source developers: accidentally checking in secrets to S3 buckets, Azure client secrets, other API keys, those sorts of things. GitHub supports validity checks across a wide variety of providers. Yes, AWS, Azure, GitHub, and Google, they're on the list, but so are hundreds of token types across dozens of providers across the globe. One of the big problems with accidentally checking in a secret is history is really difficult to purge in Git. Even if you delete the secret as soon as you find it, there are prior versions of history that people can access, so an attacker can look through your Git history, grabbing not only secrets that are in the repo, but secrets that were in the repo. There is a way to purge this history altogether, but it's not a straightforward operation. Still, GitHub will help you with that if it finds a secret in your history. GitHub even has a secret scanning partner program. If you check in something that looks like a client key or an API key, GitHub will reach out to the service and see if that string really is a valid key. If so, the service endpoint will revoke the secret and alert you to this fact. That way, even if you do accidentally leak some credentials, it limits the operational risk. I should point out that, as of today, GitHub secret scanning does not catch things like passwords in database connection strings. That said, you can create a custom secret scanning pattern to catch things like this, and I have included a link to a repo the GitHub Advanced Security team has filled with custom patterns you can use. The reason they don't have these patterns in GitHub Advanced Security itself is that they want secret scanning to have as few false positives as possible, so that means not including noisier options. That may change in the future, but as of today, if you want to catch database passwords or other secret patterns that GitHub doesn't track automatically, you'll need to create a custom rule. Still, custom rules are just regular expressions with a little fanciness added to them, so it's pretty easy to add one of these. The final feature ties back to dependency management, and that is creating automated triage rules for Dependabot alerts. This lets you ignore or snooze on a given alert if, for example, you are aware of a known security vulnerability in a package, but also know either that you're not using that section of code and your application isn't vulnerable by proxy, or alternatively, you might snooze if you know you can't fix the package version immediately due to breaking changes and you want it to show up again later. I think GitHub Advanced Security is quite powerful, and as we go into the demo, you'll see why. This demo covers Exercise 5, Task 2 of the Training on Implementing DevOps Practices. In this demo, we are going to enable GitHub Advanced Security on our repo, turning on Dependabot, secret scanning, and code scanning. We will also create a security policy markdown file and try to trigger a few issues. The first thing we need to do is go to the settings page. On here, I'll select Code Security and Analysis from the Security menu. There are quite a few options here, so let's talk about the most relevant ones to us. The first thing I'll enable is the dependency graph. This lets GitHub poke through our dependency files and build a mapping of which dependencies and versions we use. That will allow me to enable Dependabot alerts. Dependabot alerts will send me an email if one of my dependencies is out of date. I'll also enable Dependabot security updates, which will create a pull request to update a package in the event that there is a security vulnerability. Grouped security updates is a fairly new feature that tries to bundle together these pull request items. So if you have a dozen package updates, instead of getting a dozen separate pull requests, you would get a smaller number, ideally 1, but smaller than 12. Let's enable this one too. Below that, we have Dependabot version updates. This generates pull requests when packages update at all, not just after security vulnerabilities. I typically leave this one off as I don't necessarily want every update to every package. Scrolling down a bit, we have CodeQL scanning. This allows me to identify issues in my application code. To enable it, I'm going to select the Setup dropdown and then choose Advanced. This brings me to a YAML file for a new GitHub Actions workflow. We can see that it triggers on pushes and pull requests into the main branch, and there's also a cron schedule that runs once a week. You can modify this schedule if you'd like. Then, in jobs, we have one job called Analyze. Analyze uses a matrix, which allows us to analyze multiple languages in one single job. In my case, I only have C# code in this repo, but if you had C# and Python and Go and JavaScript code, the matrix could essentially act as a loop. In the Runs On section, we can see that Swift code will run on macOS, but everything else will run on Ubuntu. We have a timeout in minutes of 120 for Swift and 360 for everything else. Scrolling down into the Strategy section, here's where we define the matrix. Inside here, I have C#. If I had multiple languages, I could define separate entries for each language. For this language, the build mode is auto build. Auto build means that GitHub will try its best to build our code, but it is not a perfect process. In my case, I'm actually going to delete the build mode line as we're going to perform the build operation a little bit lower in the steps section. Speaking of the steps section, we have a few of them here. First, we check out our repository. Then, for each language in the matrix, we perform a build. What I'm going to do is remove the build mode line, as well as the check to see if the build mode is manual. Instead, I'll paste in my build steps from the earlier workflow. That will ensure that we build the .NET code. It does, admittedly, remove some of the cleverness around multiple languages in the workflow file, but seeing as how we only care about C# code in this repo, the simpler solution works well enough for us today. At the end, we have a step to perform a CodeQL analysis. I'll commit the changes into a new branch, which I'll call CodeQL. Then I'll select Propose Changes to create the PR. Let's select the Create Pull Request button, and we'll see that I need at least one reviewer. I will judge dread this by saying that I am the law. Select the Merge Without Waiting checkbox and merge this pull request. After seeing one more red button, the merge is complete, so let's delete that branch. After doing this, if I navigate to the Actions tab, I can see my CodeQL workflow in place and running. How long it takes will depend entirely on how big your projects are, how long your build takes, and how much code you have for CodeQL to scan. In my case, for this simple project, it should take somewhere between 2 and 3 minutes to complete. If I drill into the action, I can see the matrix for Analyze. Then, inside there, I can select Show All Jobs. That shows me analysis for C#. If I select that option, I can see the code scan running. There are quite a few steps involved in this action's workflow, but we'll check back in for the end result. In the meantime, let's go back to the settings page and the code security and analysis section. The next thing I want to do is enable secret scanning. To do so, I'll select the button at the bottom of the screen. This refreshes the page and gives me an option for push protection. That prevents pushing a known secret like an S3 bucket key. So we're going to enable that as well. I should note that secret scanning may take a while to run, and we can't control when it runs. Unlike code scanning, there's no YAML file we can access. Another thing I want to mention is that we do not have access to custom secret patterns. Custom secret patterns is unique to GitHub Advanced Security in the GitHub Enterprise Cloud product. My account isn't part of a GitHub Enterprise Cloud subscription, so the upshot of this is I won't be able to show you how to implement custom secret patterns. I will say, however, that it is pretty easy if you follow the instructions in the repo I've linked in the description below. Now that code scanning has completed, let's see if it found anything. To do so, I'll navigate to the Security tab. On here, I can see 3 items in the Vulnerability Alerts section: Dependabot, Code Scanning, and Secret Scanning. It looks like the Dependabot and Secret Scanning don't have anything, but we do see 1 item in Code Scanning, so let's take a look. Inside here, I can see a high alert for arbitrary file access during archive extraction, something that is colloquially referred to as zip slip. Let's drill in and see what we can learn. Starting from the left-hand side, I can see the location where CodeQL found the problem. It is in index.cshtml.cs on line 97. CodeQL mentions that this is an unsanitized archive entry and it may contain ... indicating that an attacker could try to navigate up the chain from my destination directory, extracting a zip file someplace I didn't expect it to be. If I don't understand the how behind this, I can select the Show Paths link, and that will pop up a modal dialog showing how it all fits together. We start in step 1 with the actual problem, entry.fullname. The entry variable is something that we accept directly from users, so there's no check on what a user has entered. Then in step 2, we can see the path.combine method, still on line 97. We're combining our destination directory with the full name of the zip file. Scrolling down, step 3 notes that we're saving the combined path in a variable called dest_filename. Step 4 shows how we use dest_filename to extract contents from a zip file. The particular analysis we're seeing isn't too exciting, as it just takes place over 2 lines of code. But in other cases, GitHub will note the lineage of function inputs and trace more complex problems around. So let's close this modal and go back to the alert. Next up, we get some information on what a zip slip attack is. We can see the top level explanation that this is a directory traversal attack. If that's not sufficient, we can select Show More and see more detail. And now we get a lot more detail. This gives us concrete examples of how we can get into trouble, as well as recommendations on how to fix the problem. It also gives us links to additional resources, including a video from Snike describing the topic, an entry in the Open Worldwide Application Security Project, aka OWASP, and a MITRE common weakness enumeration on the topic. I've found in real-world scenarios that there's usually a lot of good information explaining what the problem is and how to solve it. And sometimes, if GitHub knows immediately how to solve a problem, it could even create a pull request for you. Down at the bottom of the screen, we also see who introduced the problem and in what commit, so we can figure out who did it. It was, of course, Jimmy the intern, because interns exist as blame shields. Scrolling back up to the top, we have 2 buttons. On the right, I can create a GitHub issue around this, telling Jimmy to fix the problem. Alternatively, there's a button to dismiss the alert. If I select that button, I get a drop-down letting me select one of 3 options. The first is that this was a false positive, meaning that CodeQL thought it spotted a problem, but it really didn't. False positives do happen sometimes, so that is reasonable. The second option says, yes, it is an actual vulnerability, but we're using it as part of a test, and thus we want to keep it in the codebase. The final option is that we simply won't fix it. Auditors probably won't like it when they hear you've selected the third option, but it is there for the sake of honesty. Maybe this is a product that you're in the process of deprecating, or the security issue doesn't rate highly enough to bother fixing. Let's do two more things here. First, we're going to create a security file. In GitHub Desktop, I'll create a new branch called Security. This should take just a moment to create. Now that I have the branch, let's switch over to Visual Studio Code. Inside here, I'll create a new file called security.md in the root directory. Let's now paste in a sample security file. This one is obviously silly, so you'd probably want to make your own security file rather than using mine. Unless your security team is also George, in which case George is a pretty busy guy. But the idea here is that we want to let people know how they can get a hold of us in the event of a security issue, what the security notification process is, and anything else we might want to let potential vulnerability finders know. I'm going to save this file and we'll continue on. The other thing I'd like to do is see if we can trigger secret scanning push protection. I'll create a new file called config.txt. Inside here, I'll paste in an example of a GitHub personal access token and save the file. As a quick note, I've already expired this token, so it won't get very far. Let's save that file and switch back to GitHub Desktop. Now, let's commit the change locally into my own security branch. As I expected, that worked fine. But for the moment of truth, let's publish this branch to GitHub and see what it says. I'll select the Publish Branch button and I get an error. We can see that the error message is around GitHub push protection and that I have a blocked secret. Specifically, it's a GitHub personal access token in config.txt line 1. GitHub won't allow me to check in my code until I fix the problem, and I'm fine with that. GitHub does a lot to improve the security posture of code repositories, knowing that the more they catch early on in the process, the fewer security vulnerabilities make their way into the wild. And the nice thing is, most of this is also available to public repositories like mine. There are a few things you need GitHub Advanced Security on GitHub Enterprise Cloud for, but what we do get is a lot. This is also going to wrap up the series on DevOps in GitHub. If there's a major outcry for more content along these lines, I don't mind adding an extra video or two. So if you want to see something else in this series, drop a comment below, I'll see what I can do. In the meantime, we will have a new series starting next week, so stay tuned for that. And, as always, we'll have links and show notes in the description below. And until we see each other in the next video, take care.